Hi, I'm Miriam Dodt, and in my research, I want to develop a smart method for automatic and robust process control of resistant spot welding. Resistant spot welding is a manufacturing process where two thin metal plates are joined together at a very specific point. There exist two electrodes which are pressing onto both plates together strongly. Through those plates, you then send a high current for a very short amount of time. This is then melting the metal plates at the contact point. After cooling down, the two plates are joined together, forming the welding nugget. In reality and slow motion, it looks a little bit like this. Resistant spot welding is also what we call a stochastic process. This means that even if you use the same input over and over again, such as in this case, you will get different output. This is something that needs to be considered as well. For this application, I would like to develop a smart process control. What do I mean with that? Process control means that the input of a current is controlled through measurements with the goal to achieve the desired output quantity. With smart, I'm talking about a methodology that can do so automatically by itself. Further, the choice of input should be robust. This means you always choose the same input in the same situation and the similar input in a similar situation. Trustworthy, so the choice of input is leading to the desired output. For resistant spot welding, you have direct control over the current strength, the welding duration, and the force. Those are our input quantities. Indirectly, you can control the strength of the weld through the size of the nugget diameter. You can also measure this after welding, but it is very expensive, therefore we cannot do it a lot of times. Further, we can measure current, voltage, and dynamic resistance during the welding process. How can you now address process control? First of all, you need a model of the process to understand the connection between input and output. For that, there exist different types of models. The first one are what we call a white box model. They know about the physics of the process, but that makes them very complicated and slow to evaluate. They usually have a good accuracy. The second category are black box models. There, you create a simple mathematical model based on some input data. This makes it fast to evaluate, but as it is lacking the physical background, its accuracy is not always trustworthy. So you see, in some application, it's not enough to only use one of those two models. What can we do instead? We can combine them. But how? That is a very good question, because there are a million ways of doing so, and it's very complicated to choose the right one. We want a methodology that can assess its own accuracy and refine itself automatically if necessary. Furthermore, it should include knowledge about the state of the system to accurately predict the output. What is the best way to achieve this, and how can it be included in process control? That is what I have been working on for the past 2.5 years. I have looked at various methodologies that are each able to do very cool things. I would be happy to tell you more about those methods and what they can do. So please do not hesitate to ask me about them. Thank you.